Hello, everyone. My name is Fuzhong Zhao from Kobe University in Japan. And today's sharing topic is the effect and the contribution of ebook logs to model creation for predicting student academic performance. Let's start with introduction. Predicting student academic performance provides access to the building the feedback of their learning status for the instructors, which allows calculating the instruction precisely based on each student performance. With the increasing of the numerous studies, some data and its features had been used to make prediction. Parallel to this, some learning analytics techniques were taken to the predicting the practice, which has provided an opportunity to explore the relationships between the learning behavior and the learning performance. Notably, with the increasing abundance of the e-publication, a lot of reading behavior data has created novel evidence for the predicting the learning performance. However, there had been limited to the effect and contribution of the learning log data to model creation for the predicting student academic performance. As a result, a role and the structures of the log data to predict academic performance are particularly prone to be confused. Consequently, the effectiveness and accuracy of the predicting models are not adequately supportive for the educational practice. In our study, the effect and the contribution of the ebook logs were examined and analyzed in the precision of the various model creation for the predicting student academic performance. Next, the methodology. First, data collection to test the impact and contribution of the ebook logs on different model creation. And 2034 persons were recruited to the participate in an experiment. In this experiment, participants were asked to read learning material for a period, followed by a past test to make a judgment about their learning achievement. The study consists of data collection, analysis, predictive model creation, evaluation, and featuring potency of the data. The data collection is conducted through our designed the ebook system, and the learning data were stored in the log form as shown in the table 1. Finally, 11 features were composed of the prem, nest, make, highlight, bookmark, backtree, trigger rate, read time, read page, mobile, tablet, and PC. And the second step and data pressing. First, about the missing the value. And through our data analysis, we found that there are small numbers of the missing value in the data. To measure the validated of the data, we use the operation of the removing missing the value, and finally obtained the 229 participants. Also, the study performed encoding the category features for gender and represented a man and a woman as 0, 1, and 0, respectively. Also, the standardization were employed to unify the value of each figure of the data, compression the value from the 0 to 1 to avoid a class imbalanced problem. The passing score is set to the 70 points. Next is model creation. And the decision tree random forest chatbot logist regression supports vector machine and nearest neighbors are selected to construct the prediction the models for the at-risk student identification and priority functions in the sklearn were used to complete the prediction the model creation. And the basic process of to create a model was successfully consist of the train and test dataset splitting, feeding the models to parameters, mirroring the models and computing figure importance. First step is known to divide the data into the test dataset and training dataset by the sklearn built-in function. And the splitting ratio is the 3:7. And the second step is fit the model with the priority function provided by the sklearn, such as decision trees collect for is a cluster capable of the performing the classification. And we use the famous the two ways the learning curve and the grid search and to search for the optimal parameters of these models. After the creation of the models, the study followed the principle of the confusion matrix to evaluation the performance of the 6 models from the accuracy, first score, recall, precision, and AUC. The confusion matrix table consists of the prediction dimension and actual dimensions is divided 4 categories. Next, we turn to the feature importance calculation. The sklearn provides the 3 methods of for the calculating the feature importance, which were the impurity-based feature importance, coefficients feature importance, the permutation feature importance. For example, for the decision tree and the random forest and chatbots, the purity-based feature importance is more suitable. In terms of the logistic regression and SVMs, where the weight-based coefficients are the best way to identify which the best feature to contribution to the model. When calculating the feature importance of the key, the permutation, the feature importance is the best one. And without first, evaluation of the predictive performance in the values in the models. As shown in the figure 1, there are 2 distinct clustering groups measured in the predicting the performance of 6 model. The one and the former one, containing the decision tree and the forest, the random forest, and then another one containing the chatbots SVM logist regression scheme. And according to the score range of the 0.7 to the 0.8, the predictive ability of the former group is moderate and acceptable. However, the latter group is considered to have a lower predictive power because we can see the metric score of those small models ranged from the 0.5 to the 0.9 and 6. The best metric for the model prediction evaluation. In this evaluation of the decision tree model, the AUC reaches the optimal value of the 0.81, indicating that the model have the good classification ability. That's the contribution of the data feature of the model. According to the statistical results and the score distributions in the figure 1, no single feature achieved outstanding the performance in the whole mode. First, we found that the contribution of each figure varies according to depending to the different model. And second, the same phenomenon occurs in the three models with the clear the similar the algorithm principles where the figure contribution didn't have the coherency. And third, in terms of the overall the picture of the data figures, the prim, highlight, marker, and nest were found to have a greatest impact on the model prediction creation. The last one, the conclusion. For the prediction, the performance of the 5 metrics among the 6 prediction model generated by the ebook logs, the decision tree, and the random forest performed the best with a score of the 0.7 to the 0.8, which adds a actable media performance level. It's worth noting that also decision tree and random forest are the 2 separate models. Whereas the mathematics behind are almost similar. So it was concluded that the 3 models created by the book logs had a predictive performance. Also, the decision tree and the random forest are different because of the difference in the specific evaluation factor. And they differed in the best evaluation metrics. In other words, the decision tree get the highest score in the AUC, indicating the good classification performance in struct. By contrast, the random forest performs well on the record, indicating that the model had a good predictive function for the false negative. Especially, they have a good performance in predicting the performance of the true failing student. Considering the contribution of each figure in the ebook logs to the model creating, the variation which had the most significant effect on all models did not appear. Also, no universally contribution feature were found in terms of the relationship between each model and all figures. Prim, highlight, maker, and nest ranked first in the more models with the highest figure in score respective. Note that figure with the a lot of contribution to the model creation, like a prim, it has the biggest contribution in the one model, while didn't show the same advantage in other models, and they may be determined by the characteristics of the model feature selection. For decision tree, the entropy of the figure and the amount of the information of the figure is adjusted by mainly based on the gene coefficient. However, for the SAM, finding the most optimal the distance between each state and the decision surface is the most crucial problem. Then the entropy of the data is not the most critical selection criteria in this process. Thank you for listening